a eminent panel, and it is as a steel industry, it is almost like a very small family, unlike otherwise civil or concrete where it's very huge. So steel is a very small family, so wherever you go, same faces, same persons, maybe if I am not there, someone might come. So it is a familiar family. So as a family, I want to share what is that I am there to talk about. So whomever following the proceedings by means of the previous 1 month before schedule, whatever given by SSMB, it was with Dr. Saravanan, who is my senior vice president. So normally if the main cook is not there or if the main dish is not there, sometimes Upma will come and serve. So here we will see some things. Yeah, fine. So myself, Soundar. So today we are going to see only about one project, not various projects. We are going to only see only one project. I have taken from overseas, not from India. So which we have recently completed. So the project is Museum of the Future, MOTF. That's what it has been globally called. These are some of the futuristic views. So normally, on due respect to the architects make the structural life miserable, and architects normally like a painters. So they do many wonderful work, but we structural engineer, we don't understand any of them. So finally, they will come and tell, this is how you have to look at this structure. Then we will understand, wow, what is that beautiful. Yeah. So similar to this structure is also designed by Killa Design, who is very renowned in Dubai. So the round shape denotes the fertile field of earth, and you can see the greenery below, that is the earth, and the round shape is the humanity, and there is one opening is there. That opening is the unknown. So unknown is the mother for any discovery. So the total building talks about, normally we go into a museum where this museum talks about people or which is not in extinct, which is not there in the world, so some of the rare collections. So, but this museum is going to have all the futuristics one. So after 2100, what will be there? So like type of thing, that was the museum. So that's how this opening is about. So people who seek what we want to know. So that inventors one is the opening. Fine. So now coming on to my specialization, until that it is not my specializations, with due respect to the Killa Design we will be going with. And design also has been done by Bureau Harpert. We have been, I will talk about what is my scope, I will talk about that. I will give an overview of the structure's dimension. So it is 130 meter in this length in terms of structural dimension, and 61 meter in height and 39 meter in the width. Put together, it is about around 5,000 tons of structural steel, and the temporary steel, it is around 900 tons of temporary steel to add this one. So there are a few elements which is highly new to me. I am there in the industry for about 19-20 years. So these type of stairs I never seen. This is a spiral stairs going from the top to bottom. I will show the cross section of this. These are called as futuristic stairs. And there are two link bridges, North Link and South Link bridges. So I will just go through a small video. Calligraphy work, whatever done on the structure, talks what the Prime Minister wanted to tell. So those type of things has been there, and those are also the windows. The skylights come through those. owner is Dubai Future Foundation, and the architect is Killa Design, consultant Bureau Hopwood. Main contractor is BAM International. They are a Dutch-based construction company. And as a specialist steel contractor, we are there. Facade is done by Afon and MEP by Transgulf. So what is that we have done as a structural steel specialist? Connection designs, coordinated shop drawings, development of 3D models, the complete fabrication drawings, and the highly complex erection engineering, and the erection and fireproofing. So here I am going to talk about what are the challenges what we faced in construction of this particular landmark building. So the first challenge is the design table challenges, where it is more comfortable for us to sit on the design in an AC environment, which should be dealt easy. Okay, so majorly whenever we do connection designs, we take envelope of the forces. When we take a member, we collect all the members and we take what is the maximum force and we design for that particular member. Here, it is highly a complex structure, and every member, whatever it is there, it is having a different forces and different stress ratios all over this building. So that means there is total number of 2,200 members and 843 nodes is there. So all these 843 nodes, I have to design separately. Every 843 node is different and it has to be designed separately. And there are number of analysis models. There are 12 millions of forces to be dealt together. So this particular connections has been highly automated. So directly from the software, it has been directly made a program, special program to Grasshopper has been used, Idea Statica has been used, and inbuilt with a separate connection design has been made. So wherever the required stiffness, everything has been calculated, only precise to that particular node. It is no generic. And the next type of thing is the anchors. So you can see the anchors are of all are different shapes and different ones. Some are sitting on the ring beams, that periphery ring beams, and some are sitting on the pedestal. These are sitting on the pedestals. Here you can have a better view. So these are sitting on the ring beams and these are sitting on the pedestal, and the coordination with the rebars, it is highly critical and it has to be done in the design phase. It has to be done. So the next one is the interface. There are various interfaces are there, as I touched upon. So this is the amount of rebars has been put in. So everything have been put in the 3D model, and the rebar spacing and the anchor bolt spacing has been coordinated properly. And the next coordination is on the architectural envelope. So whenever the architect develops, the architectural model will be different and the structural member sizing will be different. Once the contractor has been put on board, so we have to superimpose both the models, and there are some cases where it is clashing. So based on the clashing, we have to coordinate with the architectural and we have to push those members inside. So which means that the original geometry of the member has to be redefined accordingly. So there are members which is clashing on the concrete structure too. So apart from this, these two challenges, we have this calligraphy. This calligraphy also put forward in the main Tekla model itself, so that everything has been coordinated as in one go. So these brackets, whatever you see, these for fixing of the calligraphy, and these are stainless steel facade members, including this calligraphy has been made. So, and the last one is the MEP coordination. You can see a cyan color MEP ducts which is running all over for all the utilities. Here a closer look of the MEP ducts. So these are the things where on the design front, where before we finalizing the GA drawings, it has been done. The next one is on the 3D modeling challenges. So I'll just skip it, is a bit of thing. So the major challenge, as I told, it is majorly on this future stair. Until this one, there is no software could able to produce this fabrication drawings of this particular shape. Even Tekla we tried, Tekla could not model this. Then there are some add-on packages have been made for, especially for these staircases. And I will show, this is the cross section. You have plate made trapezoidal box over here. This is going to be the stringer, which is going to be all over run, and it is in a curve shape. And this top plate, all are of 50 mm thick and 10 mm thick plates has been made, and it is made sorry, so and it is made in a spiral way, so that there is no stringer which is projecting outside. So these are some of the plates which is rolled. So the next major challenge is on the pre-cambering. Normally we all know that there is a camber, it is there, say a member, if it is having a deflection of say 30 mm and the allowable deflection of 25 mm, I will give upward a pre-camber of 15 mm or something, so that it is very well within the limit. But whenever we go for a 3D architectural shapes, whenever it is even a normal curved roof truss, where it is have to go with a pre-camber, it is highly tough one, since the total architectural geometry will change based on this. You can see the red color is the preset model, that is the pre-cambered model, and the blue color is the geometry model. So that means that I have to model, first model I have to make the original model, which I have to give for, I have to apply the connections, everything, I have to give for my MEP coordinations, everything, since that is what originally going to come. But my fabrication drawings, my internal purpose, I have to go along with this. So there is a two model has been done parallel, all the coordinations has been done accordingly. So the next one is the fabrication challenge. So as you all know that there are members which are all on 3D geometry and 3D curves. There are punch through plates welded together and the stairs. So the next one is on, yes, as a fabrication, yes, we have done. So the next one is the transportation of these particular members. So these members are having proper packaging. So all these packagings and trays, whatever it is going to carry, has been put forward for each and every assembly in the Tekla model itself, and it has been carried forward. So the next one is the AESS finish, architecturally exposed steel structure. So AESS finish. So everything has been made with the finish of that particular requirement, and the required finishing coat have been made. So this is the last challenge, which is the more interesting, and this is where we are in, is the erection engineering challenge. Yes, this is I will come on this in detail. Yes. So because of this particular one, and it is right on the Sheikh Zayed road, the requirement of temporary structures, even though for its shape is more, but it has been asked to restrict to the minimal one. So there are only major 4 temporary structures are there, and all the things are sitting over this concrete ring beam. So I'll just play this video. Analysis has been each and every time. So most probably until the main curvature comes, it is designed, it is checked for a cantilever action only. There are some members in discussion with the structural consultant, it has been revised to a higher section so that it can self-stable as a cantilever, it can be done. It is a cantilever erection only. Actually, the pre-camber, if you take the pre-camber has been calculated based on the how much is the concrete we are going to make, how far the loading, other vendor loading is going to come. So since there are various other vendors involved, so based on that the pre-camber has been calculated. So the last one, this is very common. Normally we used to do whenever we have erected a structure with a temporary tower, we have to deprop. So depropping in normal simply supported case or a fixed case, it is different, but it is like a loop. So here it is a highly challenging one when compared to our previous project, since it is a loop having a lot of hoop stresses and all. There is a special frame has been made in line with the original structure itself for basically for this uplifting operation to remove the temporary structure. Yeah, I'll just check. I'll just to conclude, I'll just share some erection photographs. So these are some of the erection photographs, progressive photographs have been made. In total, it took about 20 months for us to complete.